Now, see here. We'll start with the seventh lesson, that is gravity. So, gravity. So, what did we do in the yesterday's class? We discussed about effect of G with height and effect of G with depth. We have to do, right? Depth we have to do. Kezia, can you help me with this? Can you get a black marker from my room? Okay, just tell now that. It is in the last draw. Now, so here we'll start with the depth. What is the formula for universal law of gravitation? Formula for universal law of gravitation. Yeah, we have F is equal to G into G Ln by R square. Okay, it's the formula for D square for Newton's law of gravitation. What is the relation between small g and capital G? The second one, what we did. And what is the effect of G on height? So Gh is equal to what? G is equal to G into 1 minus H by R. G into 1 minus 2H by R. That is equal to, that is for the height. And the next one is depth. Okay, GD is equal to how much? We need to find out. Yeah. Okay, so we'll start with that now. Effect of G, gravity on depth. Okay. So now or with depth. Is it correct? Effect of G with the depth. Okay. What will happen with them? So now suppose this is the Earth. No, she is there in the room. No, it's the entrance one. You need to go inside. It's next to the door. Just next to it. Now see, this is the Earth whose radius is R. Okay. The Earth whose radius is R. Okay, now I'm drilling and going inside the ground. Okay, maybe a deep depth of 2. Now there is a new Earth, which whose radius is less than R. So let this be what? R minus D. Let this be R minus D. Clear? So now what is the formula? G is equal to, what is the formula? G is equal to Gm by R square. G is equal to Gm by R square. Now what happens here? Now the mass will change. The density remains same, but the mass is same. So what will happen? Density equal to mass by volume, right? Density equal to mass by volume. See, density remains same. Density of this and density of this is same. Mass of this is m dash and mass of this is m. Got it? The whole thing is m. The small one is m dash. Is that clear? Did you understand? The small mass. This is the Earth. We cut this part of the Earth, and the mass will not remain the same. Mass will reduce. Is it not? Is it not? So density equal to mass by volume. Mass equal to what? Mass equal to density into volume. So mass equal to density into volume. What is the volume? 4 by 3 by R cube. Why did we take like this? Volume of the sphere. Volume of the sphere formula is 4 by 3 by R cube. Now what I am going to do now? Now I am taking m dash. Density remains same. So m dash is equal to how much? Rho into 4 by 3 pi into R minus the new radius is what? R minus D whole cube. Okay. Is that clear? Is that clear? Now what I am doing here? This is on the surface of the Earth. When you go to this point, I want to find out the gravity. So GD is equal to what? Gm by R square. Gm dash by R minus D whole square. Is it okay? Is this okay? Now this is equation number 2. Now we will divide 2 on 1. We'll divide, yes please. We'll divide 2 on 1. So it will become what? So GD by G equal to how much? So it will become G into m dash divided by R minus D whole square divided by. Again what happens? Gm by R square. Now what we are going to do now? We are going to replace m and m dash values. And here we have m dash there. Is that clear? The derivation of height and depth is not the same. The way of doing the derivation for height is different from depth. Okay. Now what I am going to do, GD by G equal to how much? G into m dash. What is m dash? Rho into 4 by 3 pi into r minus d whole cube divided by r minus d whole cube divided by G into rho 4 by 3 pi r cube divided by r square. Is that clear? Is it clear, girls? Now we'll just cross multiply that. Okay, so GD by G is equal to how much? G into rho 4 by 3 pi.
So one is not continuing.
Yeah, I'm continuing. That's correct. So pi into r minus d whole cube divided by r minus d whole square into, this is r square again here, divided by 4 into G into rho 4 by 3 pi r. So G rho will go away. This all the terms will go away. Okay. What is left with us? This and this will go away. Correct?
It's R also.
So this r square, this will go. So this whole thing will go. What is left now?
R minus D by
GD by G is equal to what? R minus D by R. This is left, right? Now cross. This is GD by G equal to what? So we will take R common. 1 minus D by R divided by R. R and R will go away. Cross multiply this now. GD is equal to G into 1 minus D by R. This is the formula for depth. So what will happen? As we go deep inside the ground or into the ground, what will happen? As the depth increases, gravity decreases. As you go deep inside the ground, gravity decreases. It won't increase. It will decrease. Understood now? Again, once again, quick recap. See. Now here effect of G with the depth. So what is happening? This is the whole thing is the Earth, whose radius is r and whose total mass is m. Clear? Now density is rho. Now I am drilling and going inside the ground, that is d. Clear? So what happened? The new radius is how much? R minus d, and the new mass is m dash. So we got that. Now G is equal to what? M by r square. And we have rho is equal to density equal to mass upon volume, and mass equal to density into volume. So we know the Earth is like a sphere. So therefore, the volume of the sphere is 4 by 3 pi r cube. So now m dash is how much now? The same, the new one. How much it is? Rho into 4 by 3 pi into r minus d whole cube. Now we got the next formula. Now we will divide 1 over the r. We got this and simplify that. All the terms will get cancelled, and then you are left with this one. So take r common, it will go away. Is that clear? Is it clear, girls? Okay. So we can copy this quickly, then we'll go ahead. If you are done with this, it's okay. If you already copied. So next is gravitational potential energy. Gravitational potential energy. Okay, gravitational potential energy. So it says that now suppose this is the Earth whose radius is r. Whose radius is r. Now I want to go from at a height h1 from the ground. And it is at a height h2 from the ground. The difference is h2 minus h1. Yeah, difference is h2 minus h1. But the same thing. But what we said, if you are going from the center to this point, let it be r1. Let this be r1. And if you are going from here to here, it will be r2. This will be R2. Understood? R1 and R2. So now I want to find out the force. It is very simple. What we are doing, F is equal to G into small m capital M by R square or D square, whatever it is. Now, work done by variable force. What is the formula? Work done by variable force. Work done by variable force. What is the formula? So W equal to integration of F. Yeah.
Sir, I wanted Tanya and Dhruti and Kavya for the vaccination. Tanya and Kavya went for home. So Dhruti? Yeah. Please go to Dhruti. For 5 minutes, sir.
No. She will come.
Sir, will you?
Yeah. Congratulations.
Why is that for vaccination?
Whole night she will be having pain, right? That's it. So all of you are taken the vaccine?
No, you are
KJ, you do?
yeah, that's so beautiful.
No, did you take the vaccine?
She did, yeah.
So, okay. So R1 to R. So here what will happen? This is a work done by variable force formula. Remember this one, this is also used in, if you learn this gravitation lesson well, then you will be able to do the second lesson of the second chapter of grade 1. Electrostatic potential and capacitance. So this is the second lesson of grade 1. Whole thing, gravitation, whatever you are learning, the same concept you will utilize. But in the other sense, analogy is same. Got it? Now, so what is the W? W equal to how much? W equal to integration of R1 to R2. Then G into capital M small m by R square dr. Here, R square dr. Now, we'll go to calculus. In calculus, what he says, 1 by x square integration is what? Minus 1 by x. Minus 1 by x. Is that clear? Now what will happen? Suppose there is a limit here. Limit is what? A to B. Example. So it will become minus 1 by A to B. What is A? A is lower limit and B is upper limit. So you take that minus outside. So 1 by x from where to where? A to B. So this will become minus 1 by B minus 1 by A. This is the way we do it. Upper limit minus lower limit. So now the same way, W equal to how much? Here we write G capital M small m outside and R1 to R2 1 by R square dr. 1 by R square dr. Understood now?
Constant. Is gravitation constant.
Now here what will happen? W equal to how much? W equal to that is G capital M small m, that is equal to 1 by R minus 1 by R from where to where? From R1 to R2. W equal to minus G capital M small m into 1 by R2 minus 1 by R. So W equal to what? Minus G capital M small m by, this is the value. Now suppose if he says, see, so what is that? If we go to the what so gravitational potential. If you go to the gravitational potential, here W equal to minus GMM into 1 by R to minus 1 by R. Now here, if I take here 1 by the one point as infinity, R1 to R2, right? Suppose if I take R1 is infinity and R2 equal to R, what will happen? W equal to minus G capital M small m into 1 by R minus 1 by infinity. What is 1 by infinity? 0. So W equal to how much? Minus GMM by R. This is the formula.
So R.
We are bringing the body from infinity to the point. We are bringing the body from R1 to R2, right? Or we are taking the body from the point R to the infinity. Understood? So I suppose this is the body. I want to take the body from here to here. Is that clear? So R2 is infinity and R1 is what? The point R. Understood all of you? So I got here. So instead of writing W, I'm writing potential energy is generally denoted by V or U. Okay. See, U for potential energy, K for kinetic energy, E for total energy. E for total energy. So E is equal to what? U plus K. Understood now?
Yes.
So we got here V is equal to how much? Minus G capital M small m by R. Is it clear? So this is the formula for potential energy. Gravitational potential energy. Is it clear? Why there is a negative sign here? Why there is a negative sign here? Any idea? Yes, there. Why negative sign? Yes, why there is a negative sign? Because it is an attractive force. Whenever you drop any body, it gets attracted, right? Whenever there is attractive force, we get minus, and repulsive force plus. It goes in that way. Okay, that is how it works. Now the next one. So is it clear of you this derivation? Now we will go to escape velocity. Okay, we will go to the escape velocity, then orbital velocity, so that we can finish on this. So escape velocity is what? The minimum. What is it? The minimum speed with the minimum speed or the velocity with which the body is projected in space, such that it escapes the gravitational pull of the Earth, such that it escapes the gravitational pull of the Earth. That is said to be what? Escape velocity or escape speed. Escape velocity or escape speed. How it is represented? B. Okay, represented by B. Now what will happen here? See carefully. This is our Earth. Okay. Now what happens when your satellite is gone? It goes like this. Okay, it goes this way. So when a satellite is launched in the space, this is the point where we are giving the push. Then what will happen? It goes into the orbit. The radius is already fixed. R plus h. The orbit is fixed by the scientists. The people who are launching the satellite. We have two things. One is a satellite. One is a vehicle. PSNV, Polar Satellite Launching Vehicle. There's a vehicle. Yes, like Peninsula was a vehicle. It's not a satellite. Understood? There are two things. That vehicle means people sit in the astronaut go, sit in there, and then they go in space. The second one is what? Second is only sending the satellite only. Put it in the orbit, finish. There's no person sitting there inside. Got it? So there are two different things. So now we push it, we give a push so that once it goes into the orbit, so you don't require any fuel. Until here only we require a fuel. After that, no fuel required. After that, no fuel required. So according to the first law of motion, the body keeps stationary or in uniform motion unless it until compelled by external or periodic force. Got it? So that is how it works. Now you have two values here. The kinetic energy formula is what? The kinetic energy formula is half mv square. Kinetic energy is half mv square. And potential energy formula is minus G capital M small m by R. R plus h we are taking because this is at a height h from the ground. This is at a height h from the ground. Yeah. This is at a height h from the ground. So what we are doing now? We are going to equate both of them. Clear? So how much C R of mv square equal to minus G capital M small m by R. Is it clear, girls? Is it clear? Is this clear? Because the potential energy and kinetic energy, if they both are equal, okay, so it goes into the space, okay, with that velocity. We are keeping both the velocities equal. Now, small m and this will go away. What else is left now? So half and half v square equal to how much? Minus G capital M by R plus H. Is that clear? R plus. Cross multiply now. V square equal to how much? Minus 2gm by R plus H. 2gm by R plus H. If you are launching the satellite from the surface of the Earth, and also we know that G is equal to gm by R square. Okay. G is equal to gm by R square. Suppose if h is equal to 0, what will happen? If h is equal to 0, it will become v square is equal to minus 2gm by R. Yeah.
When we square something, obviously minus. Like minus 2.
Yeah, we will take it like that. Possible. Possible. Not it. V square. Okay, so we have the relation. What is that? G is equal to Gm by R square. So Gr is equal to how much? Gm by R. Understood now? So V square is equal to how much? 2 into Gr. So V is equal to square root of 2 Gr. This is the formula for what? Escape velocity. Understood now? Formula for escape velocity. Once again, see, we have two energies: kinetic energy, potential energy. Equate both of them and square, cancel that small n, we get that. Cross multiply and put h is equal to 0. V square is equal to 2 Gm by R. And we have G is equal to Gm by R square. Cross multiply this, Gr is equal to Gm by R. Okay. Now V square is equal to how much? 2Gr. So V is equal to square root of 2Gr. This is the formula for escape velocity. Understood?
Now, how we do when positive GM?
No, just we are taking when both the, we are not comparing the attractive force and all. We are just taking scalar values. We are only taking the scalar values. Understood? See, when you go, did you study this atomic structure? In atomic structure, did you find out the energy of the first orbital, first orbit, second orbit? What was the energy of the first orbit? You remember in chemistry? Energy, no? From Bohr's model.
Yes.
Bohr's model, you did that, right? Energy of the first orbit, energy of the second orbit. How much is? The formula is
Minus 2.18 into z square by.
that is there, but energy in simple formula, that is energy of the first orbit, general formula is minus 13.6 by n square joules or electron volts. Minus 31.36. It is minus because it is attractive there. Just substitute that n is what? Small n is principal quantum number. Substitute that value, it keeps on decreasing. The negative value decreases. Understood? The same thing. Got it. So here we are not writing negative because of the scalar value. Is it clear? Understood all of you? Now we will go to the next derivation. That is the orbital velocity. Okay. Is it clear? Can I write this part? Now. Saturday there is class. Got it. Saturday there is a birthday.
Yeah.
Birthday of 5 days. Oh. Then go ahead. So the blue is 1 by R minus 1 by R. Okay. Before this, what is the W is equal to minus C capital smaller. Do 1 by R, 1 by R equal
R1 is 1 R2.
Huh? No. Next one. No. Now here escape orbital velocity. What is orbital velocity? What is orbital velocity? DO. The speed, all the orbital speed are orbital velocity. Now suppose, see this is the part. The satellite is revolving around the Earth. Okay, this is at a height r plus h. At a height r plus h is the height from the surface of the Earth. Okay. Now the speed with which the speed with which the satellite revolves in the orbit is known as what? The speed with which the satellite revolves around the Earth in the orbit. Okay, revolves around the Earth in the orbit. The speed with which the satellite revolves around the Earth in the orbit, that is said to be orbital velocity. So in orbital velocity, what is the formula we use? Done?
Yes.
So congratulations. Now it won't. Give me textbook if you have physics book. So here we have centripetal. Yeah. So we have two forces. One is what? Centripetal force. Centripetal force is what? Or centrifugal force is equal to mv square by r, right? Equal to mv square by r. And we have G is equal to Gm by, that is, so one is centripetal force, one more force we need. There are two forces. That is equal to Gm of gravitational force, or universal law of gravitation. Gravitational force. What is the formula? F is equal to Gmm by r square. So equating both of them, and because both the forces are balanced, then only it starts moving in the orbit. If both the forces are balanced, then only it will keep on rotating around the Earth. So that is equal to what? Gmm by r square is equal to Gmm by r square. R and r will go away. V square, V and this will go away. So it is equal to what? Gm by r. So Gm by r is what? V square is equal to Gm by r, and V is equal to how much? Gr. So V is equal to what? Square root V square. V is equal to square root of Gr. This is the formula for orbital velocity. Understood now? Once again, see, the speed with which the satellite revolves around the Earth is known in the orbit is known as orbital velocity. So there are two forces. So if the satellite has to move, if the satellite is moving in the orbit, the two forces should balance. What are the two forces? Centripetal force and universal law of gravitation or gravitational force. Both the forces should be balanced. When they equate both of them, what will happen? M and R will get cancelled. We are left only with this. You know G is equal to Gm by r square, right? We know that G is equal to Gm by r square. But now, can we write Gr is equal to Gm by r? We can write, is it not? So we have Gm by r, square root Gr. So find out the square root, we get V0 is equal to how much? Square root of Gr. This is the formula for orbital velocity. Now, relation between escape velocity and orbital velocity. Relation between escape velocity and orbital velocity. So we have relation between escape velocity and orbital velocity. So what is that? We have V is equal to square root of Gr and Vo is equal to square root of Gr. So what is that? P by V0. Equation 1, equation 2 on 1. Okay, what will happen now? Sorry, 1 by 2. So we have Ve by Vo equal to square root of 2 into square root of Gr divided by root Gr. So this and this will go away. V is equal to root 2 V0. Not that V naught is not in square root. It's not under the root. It is outside the root. Root 2 V naught. Is it clear? This is a relation between linear and escape velocity and orbital velocity. Now we will discuss about the satellites. Last part of that. Time period of the satellite. That we need to discuss. Did you complete this? Write this. Just stop it there. If you have to do the time period of the satellite, then last is artificial factors. That completes our topic. It's very simple. So time period of a satellite. So time period of a satellite. So in time period of a satellite, that is capital T. Time period of a satellite is capital T. So what is that? So we have orbital velocity. So we need orbital velocity here. Why orbital velocity here? Why do we need orbital velocity in this derivative? Very good. Orbital velocity is the velocity with which the satellite is revolving around the Earth. Okay. So we have now we have I'll write a formula for that. So Vo equal to two formulas. What is Gr? The second formula is what?
Ve by root 2.
No, GM by R, right? Is it correct? These are the two formulas, right? GR and GM by R. These are the two formulas. Now we have a relation between small linear velocity and angular velocity. Relation between, what is that? Relation between linear and angular velocity. Linear and angular velocity. What is that? So P is equal to R. P is equal to no problem. Yeah, it's a cross product. It's a cross product. P is equal to R or omega cross product. Now, what is omega? Omega is equal to 2 pi nu, or it is also written as 2 pi by T. T. Clear? 2 pi by T. Now, so we can write here T is equal to what? 2 pi by omega. Can we write like this? Cross multiply. But what is omega? Omega equal to B by R, right? So right here T is equal to 2 pi by B and R. Understood now? What is the time period? This is the time period. Now, what is V? V is the what is V? V is VO here. Understood now? V naught of V0. So T is equal to how much? 2 pi R divided by root GR. Can we cut it? This will become root R, right? Root R into root R divided by root G into root R. Can we write like this?
Yes.
So this and this fellow will go over. What else is left now? T is equal to 2 pi under root R by. So this is the formula for time period of the satellite. Okay. This is the formula for time period of a satellite R by 2. Yeah. So where R is the radius of the Earth and G is the gravity. Understood? Once again from the beginning. See, we have two formulas for orbital velocity. V boy equal to root GR, V boy is equal to square root of GM by R. Okay. Relation between linear and angular velocity. V equal to R omega. Omega equal to B by R. So omega equal to 2 pi nu, or which is equal to 2 pi by 2. So T is equal to 2 pi by omega. Okay, but omega is equal to what? V by R. Just write that. Understood? So we will substitute that V0. V0 is equal to square root GR. We substitute here, and we expanded this R. So R and R will go away. We are left with this. E is equal to how much? 2 pi under root of R. Square root of R. This is the formula. Now I want to find out the time period of the satellite which is around the Earth. How much time it will take to complete one rotation? How much time it will take to complete one rotation? So we will substitute that one. Okay. So the radius of the Earth is how much? So for Earth satellite, how much it is? So it is R is equal to 6,400 kilometers, right? R equal to 6,400 kilometers. Can we write in meters? Nandana, how much it will be? Speak out, man. Don't be quiet. Yes, madam. No idea. Radhika?
Yes, sir.
Can we convert this in kilometers into meters?
Yeah.
Yeah.
Into 1,000.
Into 1,000. So how can we write down? Can we write 6.4 into 10 to the power of 6 meters? Can we write like this? And I will take, instead of 9.8, I will take 10. So that we can go on quickly. So T is equal to how much? T is equal to 2 pi under root of 6.4 into 10 to the power of 6 divided by 10. Then we make it 64 into 10 to the power of 5. Yeah. So this one will cut away, and this will become 4. It will be easy for us. Yeah. Yeah. Now, so how much it will be now? T is equal to 2 pi under root of 64 into 10 to the power of 4. So what is root 64? 8. T is equal to 8 into 2 pi into 10 to the power of 2, right? Yeah. So it will become how much? 16 pi into 100. How much it will be? T is equal to 1600 pi. So T is equal to how much now? It's coming in seconds. It's coming around how much it will be? 1600 into maybe 1600 into 5, 3.14. Maybe something around it is showing 85 minutes. Means what is the meaning of this? Means if the satellite is revolving around the Earth, how many times how much time it will take to complete one rotation? How many times? How many minutes?
85 minutes.
85 minutes. Means 45 minutes approximately 1.5 hour, 1 hour 15 minutes. Can you understand how fast it is? How fast it is? In 1 hour 15 minutes, the satellite completes one rotation. Then suppose the astronaut is sitting in the satellite and he is moving in the how fast it is. Yeah, how fast it is. Understood? So a person who sits in the satellite and moving around the Earth, he can see the moon and sunrise 18 times. Sunrise and sunset, how many times? More than 18 times. Understood? That's how fast it is. So that is why then now we'll speak about space junk. Space junk, you know? What is space junk? Huh? Now the problem faced by the scientists is space junk. What is space junk? Junk in space, okay? Yeah. Now we are launching the satellites in the space. Okay. They are rotating continuously. Now the satellite will work for 10 years or 12 years or 15 years. Okay. Then it will become a what we say unused satellite. There is a name for that. It starts with a D letter. I don't know. So it becomes an unused satellite. So again we have to launch new satellite for that purpose. Okay. So clear all of you? Now. Now, okay, it's the time frame. Then after that, we have artificial satellites. We discuss about artificial satellites. You know about natural satellites, right? What are natural satellites? What are natural satellites? Moon and Venus. How many satellites we have on Mars? Jupiter 11, Mars 5. Natural satellites. Okay, it's 5 moons we can say. Okay. Why are people struggling to go to Mars? They are jobless somehow. Why are they struggling? There is no air, nothing is there on Mars. Why people are struggling to go to Mars?
Then something is being found.
What did they find? Why people are very anxious? Especially Elon Musk. He made so many launch vehicles and all. What happened? Elon Musk, did he say something? Because behind his Mars projects, right? So many projects. So now artificial satellites, we have two types of satellites. Now, this is what? Going back to Indian geography. Was very good at social studies. Was the second topper of my school. Yeah. Geography especially. So we know latitudes, longitudes, right? In geography, like North sir. Okay. So we know latitudes, okay, 0 degree latitude, and we have geographic north and geographic south. You know that. Now a satellite is moving. Suppose there are two types of satellites. One satellite, it goes like this, and one satellite goes like that. This orbit is said to be what? This is said to be geostationary satellite. Geostationary. Is it correct? Geostationary satellite. Okay. So once I wrote I was writing the guidelines for the teachers, and I wrote stationary. Stationary means I wrote like this in the guidelines to the teachers. So ma'am found out this thing. She told stationary means stop. Stationary means the books and all, right? So that means what do you understand from this? See each and every thing. There are so many 35 points. You literally found out that also. Got it? So this is polar satellite. So this is polar satellite. Okay. So polar orbit and stationary orbit. Polar orbit means goes on the poles. So generally the height of this polar orbit is around 800 kilometers. And this height is around 36,000 kilometers. And the time period is around 85 minutes. And time period is equal to 24 hours. What is the meaning of 24 hours? What is the meaning of 24 hours? Means along with us, it also sees the sun one time, sunset and sunrise only once in a day, right? Like us. Means they are geometrically stationary. Geostationary means geometrically stationary. Suppose Dubai is here, satellite is here. Dubai is here, satellite is here. Dubai is here, satellite is here. Means exactly parallel to the surface of the Earth. Exactly parallel to the surface of the Earth. Understood now? It's every time it is above the country only. It is every time. So, but there is a height. So, how fast it has to move such that it should be parallel to the surface of the Earth. You know, the Earth is also rotating, right? How much is the rotation in 1 second? Earth is rotating, right? You all know rotation, revolution, studying from grade 1. Earth is rotating about itself, and Earth is also rotating around the sun. Yeah. So, how fast it is rotating? It is rotating 2 kilometers in 1 second. It's rotating 2 kilometers in 1 second. Are you feeling it? 2 kilometers we can, but the person who stands on the top of the person, if I can feel that by movement. Yeah, because we are sitting on a stationary. But that cannot happen when you are flying in the aeroplane. It doesn't happen, right? Because both are in motion, right? But here in this case, what happened? Burj Khalifa is stationary. When you climb on the top of the Burj Khalifa, you can feel that like movement. Understood now? Movement of the earth. Okay. Yeah. Yeah, sweet. Okay. Now what happened? Next one. So time period is, so how fast it has to move? Now, Earth is moving 2 kilometers in 1 second. Then that satellite is to move how many kilometers in 1 second? If it is 2, then it cannot match, right? Because see, this is Earth, and the satellite is the orbit. Look at the orbit. If this is R, this is R plus H, right? Spark, the radius is more than the R value. It has to move faster, right? Or faster. The satellite has to move 8 kilometers per second. Who is faster? Who is faster? This is faster or that is faster? Polar. Think.
Isn't polar like goes through a lot of times. It's only goes in one.
Geostationary goes fast. Okay. But there is one more question here. Geostationary is at a height of 800 kilometers, and this fellow is at a height of 36,000 kilometers. Can you substitute in this formula and see who is faster? Can we see? dV is equal to what? Square root of GR, right? G, calculate G into R plus H. Yeah, then we will substitute here R. One for the polar and one for the geostationary, and tell me the answer, which is bigger. Okay, that we can do it. That exercise we can do later. Not a problem. Now, when it is used, this is advantages. They are using remote sensing. Remote sensing. Have you seen this movie Parman? Hindi movie. Parman. Very nice movie. This was done by APJ when APJ Abdul Kalam was the president of India, and Atal Bihari Vajpayee was the prime minister of India. At that time, India did one, nuclear exercise in Rajasthan. Pokhran, I think, somewhere. They did this experiment. When because of which India was banned in most of the agreements. Okay, but it was a very big experiment. So how could not? Because there are some satellites, army satellites and space satellites are there, which are monitoring continuously what is happening in other countries. Especially US satellites are there. They are focusing on the borders of the countries. What is happening? India-Pakistan border. Yeah, all the borders will be continuously because it is rotating how many times? 1 hour 15 minutes it is coming back. Now suppose the time is 8:34. Maybe after 11, maybe 11:45, again it will come back to Dubai. So it is taking pictures and sending it to the ground stations. So that is how they monitor what is happening at the borders. Understood now? So in that duration, within 1 hour, they need this. When the satellite skip, the second satellite comes, the next point. In that 1 hour, they need everything. That is how they manage all this thing. Okay, now, so that is remote sensing. Remote, not only that, where suppose this also gives the information to the airlines. Like suppose there is one example. Like when the Airbus, I think it was Airbus A380, it was flying from Australia to China or Singapore, I don't know. There was a volcano explosion took place, and that flight had landed. There was emergency landing. In the flight, all the fan, it did not. The engine stopped working for some time, and again started working. But when they landed, all the engine was damaged. Why? Because this volcano has a smoke and particles. That particles went into the engine, and they damaged the whole engine. Because they become rock, right? The liquid becomes rock, sedimentary rock. I don't know what is the rock. When they become cool, they become rocks. So all I don't know what it is. Igneous rock. They become small pieces of rock, and it has damaged the whole engine. So how did they come to know? Later on, they came to know from the satellites. Yeah, there was explosion. That volcano eruption was there. So that was also a lesson to the airlines. Understood? So remote sensing is everywhere. Agriculture, what is happening in which country, where the forest is on fire. All this information is done by remote sensing. Drought or agriculture or excess rainfall. All this is done by remote sensing. And the next one here, geostationary satellite is used for communication purpose. Okay, communication purpose. Like the channels, NDTV, Z channels and all, many are there, right? Z News and all. Okay, BBC, all this work on communication. This is satellite communication. Understood now? So this computation is.
So which is fast polar?
That is you have to find out. That is a small thing I have. Okay, R is equal to what? R is 6,400 kilometers. Okay, so shall we try? V is equal to first case polar for polar. I'm trying for polar. So for polar, how much it is now? G is 10. I'm taking R is 6,400 plus 800 kilometers. Now for geostationary, how much it is? V equal to under root of 10 into 6,400 plus 36,000. Do it now. Can you tell me the value? How much it is? 6,400 plus 800 will become 72, right? No, not 72. So 72,000. 72. Yeah, 7,000. One more will come, right? 72. Is it correct? What about this? 36 plus
10,000.
No, this is 36,000.
Oh.
How much it will be?
42,400.
42,400. So yeah, 42,400. Sorry, 42,400. Again, one more zero, right? Now who is bigger? This is bigger, right?
Yes.
So geostationary satellite has more speed. Understood now? Is it clear? This is how the MCQs are tricky. Apparently, got it? Understood now? So please, these are very small questions, but they make you confused in the examination. So that is why never try MCQs in the beginning. That will spoil your brain. Whatever you study, that also will go. This is what I learned in my career. Or you can leave the numbers 1, 2, 3, 4 up to 16 and go to the section. Later on also you can write, right? We are not going to write the solution over there for 1 mark. Is it not? Clear? So, thank you so much.
Thank you, sir.
So I'll post this video. Okay.